Hello, space enthusiasts, and welcome back to our channel. Today, we're diving into a cosmic mystery that has astronomers scratching their heads. We're talking about a visitor from another star system, a comet so bizarre it seems to delight in breaking every rule we thought we knew. Its name is 3I Atlas, and its story is one of the most perplexing and fascinating tales in modern astronomy. So, what makes a comet a comet? For centuries, we've had a pretty solid picture. They're often called dirty snowballs, icy bodies that heat up as they approach the sun, releasing gas and dust to form those spectacular tails we love to see. They follow predictable orbits. Their brightness changes in a certain way, and their chemical makeup tells a story of their origin. Simple, right? Well, 3I Atlas looked at that rule book and decided to tear it to shreds. This isn't just one anomaly, it's a whole series of them. A cascade of cosmic weirdness that challenges our fundamental understanding of these celestial travelers. And the most exciting part? No one has a definitive explanation. Let's start with the first broken rule, its origin. The I in its name stands for Interstellar, meaning it's only the third such object we've ever confirmed. Like its predecessors, Oumuamua and Borisov, it's a wanderer from deep space, a messenger from another star. But that's where the similarities end. While Borisov behaved much like a typical comet from our own solar system, Atlas is in a league of its own. It's not just an outlier, it's practically a different species. This immediately tells us that the comet factory it came from might operate under completely different conditions than our own Oort cloud. That S-rule number 1 shattered. Not all interstellar visitors play by our solar system S-rules. Rule number 2, the tail. A comet's tail is its signature feature. It's formed when solar radiation vaporizes ice on the comet's surface, and the solar wind pushes the resulting gas and dust away from the sun. Simple physics. But ATLAS's tail was strange. It was incredibly long and unusually narrow, almost like a perfect, thin line drawn across the sky. Most comets have broader, more diffuse tails, often with separate dust and ion tails pointing in slightly different directions. ATLAS's singular, pencil-thin tail defied this classic model. It suggested a very specific and highly unusual outgassing process was at play. What could cause such a focused, streamlined jet of material? The mystery was just beginning. Then came the third broken rule, its color and composition. By analyzing the light reflected off a comet, we can figure out what it's made of. Comets from our solar system are rich in water ice, carbon monoxide, and other volatile compounds. Borisov, the second interstellar object, fit this profile perfectly. It was a familiar face from an unfamiliar place. But Atlas? Spectroscopic analysis revealed it was incredibly poor in carbon. This was a shocker. Carbon-based molecules are fundamental building blocks in the cosmic clouds where comets form. A comet that's carbon deficient is like a cake made without flour. It raises a huge question. What kind of bizarre stellar nursery did Atlas form in? One that was mysteriously starved of one of the most common elements in the universe? This leads us to rule number 4, its brightness curve. As a comet gets closer to the sun, it gets hotter and releases more gas and dust. So it should get brighter in a predictable way. Astronomers have mathematical models for this, but 3I ATLAS laughed at those models. Initially, as it journeyed toward the sun, it brightened far more rapidly than expected, leading to predictions that it could become a magnificent sight in our night sky. But then, long before it reached its closest point to the sun, it just stopped. It hit a plateau in brightness and then began to fade, completely defying expectations. This erratic behavior was a giant red flag that something was fundamentally unstable about this object, and that instability brings us to rule number 5, structural integrity. We know comets can break apart. It happens. The gravitational pull of the sun or a large planet can be too much, or they can simply run out of volatile ices holding them together and disintegrate. But these breakups usually happen near perihelion, the closest point to the sun where the thermal and gravitational stresses are at their peak. 3-1, ATLAS decided to do things differently. It began to fragment while it was still incredibly far out, beyond the orbit of Mars. It wasn't under extreme stress. It just fell apart, seemingly on its own terms. It didn't just crack, it shattered into multiple pieces. A catastrophic failure that happened way too early in the game. This premature disintegration is linked to the 6th broken rule, its rotation. By observing the light patterns from a comet, we can determine how fast it's spinning. Most comets have relatively stable rotation periods, but observations of Atlas suggested it might have been spinning itself to death. The idea is that as it heated up, uneven jets of gas acted like tiny rocket thrusters, spinning the nucleus faster and faster. Eventually, the centrifugal force could have become so strong that it literally ripped the comet apart from the inside out. While this spin-up mechanism is known, for it to happen so far from the sun and with such destructive force is highly unusual and points to an incredibly fragile internal structure. Which brings us to Rule 7, its density. We can't weigh a comet directly, we can infer its density from how it behaves, based on how easily Atlas disintegrated. Astronomers concluded it must have an extraordinarily low density. We were talking about a density perhaps no greater than that of a pile of freshly fallen snow, or even cotton candy. Our own solar system's comets are dirty snowballs, but they are relatively compact. Atlas seems to have been more of a fluffy dust bunny, barely held together. This extreme fragility is unlike almost any comet we've studied up close, and again points to a very different formation environment. Rule number 8 involves its trajectory asterisk after asterisk fragmentation. When a comet breaks up, the pieces usually continue along a similar path, spreading out gently like a string of pearls. The fragments of 3I ATLAS, however, were pushed apart with surprising vigor. This suggests that the breakup wasn't a passive crumbling, but a somewhat energetic event. Pockets of supervolatile ices like frozen nitrogen or carbon monoxide might have been exposed and vaporized explosively, acting like tiny engines that propelled the fragments away from each other. This implies a non-uniform composition, with volatile bombs hidden inside a less active shell. Let's talk about rule number 9, the nature of its dust. The dust shed by a comet tells us a lot about its parent body. Typically, its dust is a mixture of silicates and organic compounds. The dust from Atlas, analyzed through its light scattering properties, appeared to be different. It behaved as if the grains were larger and fluffier than typical cometary dust. This ties back to the low-density hypothesis. It suggests the entire comet, from its core to the dust it sheds, was built from exceptionally porous, fluffy material. It's as if the entire object was constructed from cosmic aerogel. Finally, the 10th and perhaps most profound broken rule, it challenges the very definition of a comet. We have a neat little box for comets and another for asteroids. Comets are icy and active, asteroids are rocky and inert. But objects like 3I ATLAS blur these lines completely. It came from the cold depths of interstellar space, so it should be icy. It was active, producing a tail, so it acted like a comet. But it was carbon poor and fell apart with baffling ease, behaving unlike any comet we know. Was it a pristine, unprocessed relic from the dawn of another solar system? Was it a fragment of a larger, Pluto-like dwarf planet from that system, shattered by some ancient cataclysm? Each of these 10 anomalies is a fascinating puzzle on its own. But when you put them all together, you get a profile of an object that defies easy categorization. 3I, Atlas wasn't just a visitor, it was a cosmic enigma sent to challenge our assumptions. It forces us to ask, how diverse are comets across the galaxy? Are our solar system's comets the exception or the rule? What other strange formation processes are happening around other stars? The story of 3I, Atlas, is a perfect example of why science is so exciting. It's not about having all the answers. It's about finding questions you didn't even know you should be asking. This interstellar traveler, though it has long since disintegrated and faded from view, has left a permanent mark on astronomy. It shattered our rule book and, in doing so, opened up a universe of new possibilities. The cosmos is weirder, more varied, and far more wonderful than we could have imagined. And we can't wait to see what the next interstellar messenger will teach us. Thank you so much for joining us on this deep dive into one of space's greatest current mysteries. What do you think explains the bizarre behavior of 3I ATLAS? Let us know your theories in the comments below. And if you love exploring the strange and wonderful corners of our universe, make sure to hit that like button and subscribe for more cosmic adventures. See you next time.